Hey everyone, welcome back to the Code Professor. Today we are diving into Entity Relationship Model or ER model, a functional concept in database design that will make understanding database much easier, right? Whether you are a beginner or brushing up your skills, this video is for you. Let's get started, right? What is an ER model? It is a conceptual model for designing a database, right? It represents the logical structure of a database, including entities, their attributes, and relationships between them, right? Think of it like a map of database, right? I briefly discuss these things now, after which I hope to discuss them deeply, right? An entity is an object that is stored as data. Simply remember, it is a thing, right? Attributes are properties that describe an entity such as student ID, course name, or employee email, right? A relationship is a connection between entities, such as when a student enrolls in a course. Student and course have a relationship, right? The graphical representation of this model is called an entity relation diagram, right? ERD. When designing a database, we usually follow these steps, right? The first one is gathering requirements by asking questions to the database users. The second one is creating a logical or conceptual design of the database. This is where the ER model comes into play. It is the most used graphical representation of the conceptual design of a database. After this, we finally focus on the physical database that represents these entities. Okay. Let's dive into a deep discussion of entities. An entity represents a real-world object, concept, or thing about which data is stored in a database. It acts as a building block of a database, right? Tables in relational database represent these entities, right? Example of real-world objects: person, cars, employees, etc. Right? Examples of concepts are course, event, reservations, etc. Right? Example of things: product, document, device, etc. Right? Row is an entity, right? See? Okay. Entity types. It is a collection of the entity having similar attributes, right? We have each row as an entity and they are having common attributes, right? Each row has its own value for attributes, right? See, own values. Roll number, student name, age, and mobile number. So we can define the student table as an entity type because it is a collection of entities having the same attributes, right? The table below, this table shows how the data of different entities are stored, right? What is the entity set? The collection of entities of the same entity type is the entity set, right? See, student entity type, a collection of entities from the student entity type would from an entity set, right? Would form an entity set, right? We can say that entity type is a superset of the entity set as all the entities are included in the entity type, right? You can see this is the entity set. This is the example for this, right? E1 and E2 is the are the entity set. Okay, we have two types of entity type, right? What are they? First one is strong and second one is weak entity, right? Okay, first one is strong entity. It is an entity that can be uniquely identified by its own attributes, right? It does not depend on any other entity of exist. It has a primary key that uniquely identifies each instance. It is represented in an ER diagram as a single rectangle, right? We use this for representing an entity. Okay. In this table, roll number is the strong entity, right? It uniquely identifies each employee. Weak entity. A weak entity cannot be uniquely identified by its own attributes alone, right? It depends on a strong entity to exist. Its primary key is parallelly dependent on the strong entity. It's represented in ER diagram as a double rectangle like this. Okay, it is connected to the identifying strong entity with an identifier relationship. This is the relationship. We can represent it using double diamond shape, right? Okay. Attributes are the properties that define the entity type, right? Roll number, name, course are the attributes, right? Okay. In ER diagram, the attribute is represented by an oval shape. See? Okay. Let's talk about types of attributes one by one. First one is atomic attributes, right? An atomic attribute is an attribute that cannot be divided further into smaller meaningful parts, right? It stores one single value for each entity. Examples: age. Age is equal to 21. This cannot be split into useful smaller values. Okay, and employee ID is equal to E102. One single value for identification, right? Atomic attributes are represented by a single oval connected to the entity, right? They make database design simple and efficient. They help maintain one value per field, which follows first normal form in DBMS. Most attributes in everyday tables are atomic, like ID, marks, price, category, likewise. The second one is composite attributes, right? An attribute composed of many other attributes is called a composite attribute. For example, the address attribute of the student entity type consists of street, city, state, town, country, likewise, right? In an ER diagram, the composite attribute is represented by an oval comprising ovals, right? Oval comprising ovals, right? Okay. Then the next one is the single valued attributes, right? It is an attribute that stores only one value for a particular entity. It cannot hold multiple values at the same time. It represents a single fact about entity. It helps maintain clean and structured data, right? What are the examples? A student has one date of birth, right? It is single valued. An employee has one NIC number, right? It is single value, right? We can represent it represented by an oval, right? The next one is multi-valued attributes, right? An attribute consisting of more than one value for a given entity, for example, phone number. It can be more than one for given student, right? In ER diagram, a multi-valued attribute is represented by a double oval like this, okay? The next one is stored attributes. A stored attribute is an attribute whose value is physically saved or stored in the database, right? It is directly entered and kept as actual data, not calculated, right? What are the examples? A student's date of birth is stored as an exact value, right? An employee's salary is stored because it is not derived from anything, right? It is shown as regular oval in ER diagrams, right? It is used as the basis to compute derived attributes, right? The next one is derived attributes, right? And attributes that can be derived from other attributes of the entity type is known as a derived attribute, right? Example, age. In ER diagram, the derived attribute is represented by a dashed oval like this, right? Okay. Key attributes. A key attribute is an attribute that uniquely identifies each entity in an entity set, right? No two entities will have the same value for this attribute, right? And it is the unique identifier for the entity. Example, two students can have the same name, same age, but they cannot have the same student ID, right? So, student ID is a key attribute, right? How can we represent it? A key attribute is underlined inside an oval shape, right? We can represent key attributes like this. Okay. Oval is attribute. Underline identifies it as a key attributes, right? Okay. Why key attributes are important? They are uniquely identified records. They help avoid duplicates. They are used as primary keys in relational tables. They maintain data integrity, right? Okay. It is used as primary key in database tables, right? Example, student ID, employee ID, NIC, register number, likewise, okay? What is a domain? The domain of an attribute is the set of all possible valid values that an attribute can take, okay? Think of it as the allowed values list for that attributes, okay? Simple definition, domain is equal to the range of acceptable values for an attribute, right? Values outside this domain are not allowed, okay? I think you can get the idea, right? Domain mean range, right? Why domain is important? Domains help the database maintain data integrity, prevent invalid data, ensure consistency, enforce constraints. Okay? In ER diagrams, when we define an entity, each attribute has a domain. Example, we can get student, age should be integer, name should be string, GPA should be float. Here domains are integer, string, float, right? Real life analogy. A domain is like relationship types and relationship set. A relationship type represents the association between entity types, right? For example, enrolled in is a relationship type that exists between entity type student and course, right? In ER diagram, the relationship type is represented by a diamond and connecting the entities with line. See, using the lines, entities connected. Okay. Relationship set. A relationship set is a collection of similar relationships between two or more entity sets, right? Two or we can do like this. Now this is the relationship set, okay? Right. Degree of a relationship set. A relationship set is a collection of similar relationships between two or more entity sets, right? What is the degree? Degree is the number of different entity sets participating in a relationship set is called the degree of a relationship set, right? First type of degree is ordinary relationship set, right? When there is only one entity set participating in a relation, the relationship is called a ordinary relationship, right? For example, one person is married to only one person, right? The second one is binary relationship. When there are two entities set participating in relationship, the relationship is called a binary relationship. For example, student is enrolled in a course. Student and course are the entities, right? What about ternary? Ternary means when there are three entities set participating in a relationship, the relationship is called a ternary relationship, right? Like this. Third entity enrolled this, right? Therefore, we can call it as ternary relationship, right? N-ary relationship. When there are n entities set participating in a relationship, the relationship is called an n-ary relationship. Like this, right? See, there has 4 entities, right? Okay. Cardinality in ER model. The maximum number of times an entity set participates in a relationship set is known as cardinality, right? Cardinality can be of different types. First one is one-to-one. When each entity in each entity set can take part only once in the relationship, the cardinality is one-to-one. Let us assume that one person can be issued only one passport and one passport is issued to only one person. So the relationship will be 1-to-1, right? Meaning that each person has a single passport and each passport belongs to a single person, right? We can represent it like this. Okay. Next one. In a one-to-many relationship, one entity can be associated with multiple entities. For example, a single surgeon department can have many doctors. Therefore, the cardinality of this relationship is 1-to-many, meaning one department can have many doctors. We can represent it like this, okay? When entities in one entity set can take part only once in the relationship set, and entities in other entity sets can take part more than once in the relationship set. Cardinality is many-to-many, right? Let us assume that multiple surgeries can be performed by one surgeon, but one surgery is performed by only one surgeon. So the cardinality will be many-to-1, right? Meaning that many surgeries can be done by a single surgeon, but each surgery is done by only one surgeon, right? When entities in all entity sets can take part more than once in the relationship, cardinality is many-to-many. Let us assume that an employee can work on multiple projects and each project can have multiple employees working on it. So the relationship will be many-to-many, meaning that one employee may be associated with several projects and one project may involve several employees, right? Next topic is participation constraints, right? It is applied to the entity participating in the relationship set, right? We have two types, total participation and partial participation. What is the total participation? Each entity in the entity set must participate in the relationship if each student must enroll in a course. The participation of students will be total. Total participation is shown by a double line in the ER diagram, right? Like this, okay? Partial participation. The entity in the entity set may or may not participate in the relationship. If some courses are not enrolled by any of the students, the participation in the course will be partial, right? The diagram depicts the enrolled in relationship set with student entity set having total participation. This is total participation and this is the partial participation, right? Okay. If you get something from this video, don't forget to subscribe us, like, comment and share with your friends. Bye bye.